A Sri Lankan mahout named Podi Appu spent 40 years working with the same elephant, an animal named Raja, waking before dawn to walk her to the river, scrubbing mud from her legs, learning the difference between the low rumble she made when she was hungry and the one she made when a stranger got too close. Raja could uproot a tree without much effort. She could crush a car if she wanted to. She never once did either to the man who spent 4 decades at her side. And yet for all that trust, all that decades-long partnership, Raja was never domesticated. She had been tamed. Every elephant working alongside a human today, whether it hauls teak logs through the forests of Myanmar, carries tourists near a temple in Kerala, or performs in a procession lit by torches, was born from a wild mother and shaped by wild genes that no breeding program ever touched. Horses stopped being wild more than 5,000 years ago. Dogs stopped being wild more than 10,000 years ago. Cattle, pigs, goats, all reshaped by selective breeding into animals that no longer resemble their wild ancestors. Elephants never stopped. If you're enjoying this story so far, don't forget to hit the like button and subscribe. Drop a comment telling me where in the world you're watching from. I love hearing from you. Camels, reindeer, even the humble domestic duck, all crossed that same threshold at some point in the deep past, becoming animals whose bodies and instincts were reshaped generation after generation to fit human needs. The elephant crossed the threshold of usefulness without ever crossing the threshold of domestication, and the 4,000 years since have not closed that gap. Humans have worked directly with elephants for at least 4,000 years, since carved stone seals from the Indus Valley civilization first show them wearing cloth and rope. That is longer than the written history of most nations on Earth, and in all that time, across dozens of cultures on 2 continents, nobody managed to do to the elephant what herders did to the aurochs, the wolf, the wild boar, and the wild horse. Nobody built a self-sustaining, human-controlled breeding population that grew calmer and more predictable with every generation. The puzzle is not why humans failed to notice that elephants were useful. They noticed almost immediately. The puzzle is why 4,000 years of trying, some of it backed by the wealth of entire empires, never once produced a domesticated elephant. The obvious explanation is size. A horse that panics can hurt you. A bull elephant that panics can kill an entire pen of cattle by accident, simply by walking through them without breaking stride, and a set of tusks only raises the stakes further. This explanation feels complete, right up until you remember that humans domesticated the aurochs, the massive wild ancestor of modern cattle, an animal that stood well over 6 feet at the shoulder and used horns built like weapons against predators twice its size. Humans also domesticated the wild boar, an animal still known today for charging when cornered, and tamed dromedary camels that can kick with enough force to break bone. Even the cheetah, kept for hunting by royal courts stretching from ancient Assyria to Mughal India, was never domesticated either, for reasons that turn out to rhyme with the elephant's story more than most people expect. Size and danger slowed domestication down in every one of those cases. They did not stop it. Something else about the elephant made the difference between slow and never. That something starts with a number most people have never had a reason to think about: 22 months. That is how long a female elephant carries a single calf, the longest gestation of any land animal alive. A mare carries a foal for about 11 months, roughly half as long, and can often conceive again within a year of giving birth. A cow carries a calf for about 9 months on a similar yearly cycle. An elephant cannot work that way. After giving birth, a female elephant typically waits 4 to 5 years before having another calf, nursing the first one through a childhood that can stretch past a decade in the wild before it is considered independent. A female elephant does not usually have her first calf until her mid-teens, and across a lifespan of 60 or 70 years, a wild female might produce only 4 calves in total. A domestic mare, over a similar working lifetime, can produce 15 foals or more. Female elephants also keep living for decades after their last calf is weaned, a trait shared with only a handful of other species, humans and certain whales among them, spending their final years passing down memory rather than adding to the population. None of that helps a breeder trying to build the next generation faster. Selective breeding works by comparing many offspring against each other within a single generation and choosing the best of the litter to become parents of the next one. A litter of 8 foxes lets a breeder discard the 7 that are still skittish and keep the one that is calm. A single elephant calf, born once every 4 or 5 years, gives a breeder nothing to compare it against and no discard pile to choose from. Research led by the biologist Mirka Ladenpera, using the same long-running Myanmar elephant records discussed later in this story, found that grandmother elephants measurably raise the survival odds of their grandcalves, an echo of similar findings in human and orca families. That long post-reproductive lifespan is remarkable in its own right, but it adds years to an elephant's total lifespan without adding a single additional calf to work with. For anyone hoping to breed elephants the way herders bred horses, this is close to a mathematical wall. The biologist Jared Diamond laid out the underlying logic in his 1997 book Guns, Germs, and Steel, describing what he called the Anna Karenina principle. A candidate for domestication has to clear several separate hurdles at once, including diet, growth rate, and a willingness to breed under human control, and failing even one of them can rule the species out entirely, no matter how tame individual animals seem. Slow reproduction alone can sink the whole project, because domestication does not happen to an individual animal. It happens across generations, as breeders repeatedly select the calmest and most cooperative animals to produce the next batch, gradually reshaping the species' genetics and behavior year after year. The Soviet geneticist Dmitry Belyaev showed exactly how fast that process can move, given a fast-breeding animal to work with. Starting in 1959, at a research station outside Novosibirsk, Belyaev bred silver foxes for a single trait: calmness around humans. Within about 10 generations, some of his foxes were behaving like dogs, wagging their tails, seeking out human affection, even developing floppy ears and patchy coats that had nothing to do with the trait he was actually selecting for. Because foxes breed once a year and reach sexual maturity within a year of birth, 10 generations took roughly a decade to complete. The experiment, continued today by the geneticist Ludmila Trut, remains one of the clearest demonstrations that domestication is fundamentally a numbers game, a matter of how many breeding cycles a person can run before they die. Run that same math on an elephant. 10 generations, at a generation length of roughly 22 years, for a female elephant having her first calf in her mid-teens and living into her 60s, would take well over 200 years to complete. No single breeder lives that long. No single unbroken line of breeders, handing the project down from parent to child with perfect continuity, has ever managed to stay focused on one elephant breeding program for that stretch of time. The Ptolemaic dynasty of Egypt, one of the most stable and elephant-obsessed royal houses in ancient history, lasted around 275 years, and its interest in elephants was military and immediate, not generational and selective. 10 fox generations fit comfortably inside a single human career. 10 elephant generations do not fit inside most human institutions, let alone a single human life. Reproduction speed is only the first wall. The second is appetite. An adult elephant eats somewhere between 100 and 150 kilograms of vegetation a day, grasses, bark, roots, and fruit, and drinks close to 200 liters of water when it can find it. In the wild, a single elephant family might range across several hundred square kilometers over the course of a year, following seasonal food and water the way its mother and grandmother taught it to. A horse, by comparison, can be sustained on a few hectares of managed pasture, supplemented with grain, because its digestive system extracts more energy per kilogram of food, and its body is a fraction of the size to begin with. Turning a wild species into a domesticated one requires keeping a breeding population confined and fed for generation after generation, which means the cost of confinement has to be survivable for the people footing the bill. Cattle, sheep, goats, and horses could all be fed on land a single farming household could realistically maintain. A breeding herd of elephants large enough to run real generational selection, the kind Belyaev ran with his foxes, would require feeding dozens of animals that each eat more in a week than a horse eats in a month, on land that could otherwise support far more cattle, far more grain, or far more people. No agricultural society in recorded history had a surplus large enough to make that trade worthwhile for an animal that would not pay off, reproductively, for decades. Ancient armies that kept war elephants understood this cost directly. Feeding a single campaign elephant required roughly the same daily ration as several horses combined, and generals marching elephants long distances had to plan supply lines around them the way modern armies plan fuel convoys around tanks. Breeding elephants for calmness across generations, rather than simply feeding and training the ones already captured, would have multiplied that logistical burden across every animal added to a captive population that was not yet useful for anything. The third wall is social. Wild elephants live in tight matriarchal family units, daughters, granddaughters, sisters, and aunts, staying together for life under the leadership of the oldest and most experienced female, while young males eventually leave to live alone or drift between loose bachelor groups. Younger females, sometimes called allomothers, help care for calves that are not their own, a cooperative structure that keeps the group functioning as a single unit rather than a collection of individuals. Cynthia Moss, who began the Amboseli Elephant Research Project in Kenya in 1972 and has tracked multiple generations of the same families ever since, documented just how much of an elephant's behavior depends on decades of knowledge held by the matriarch. Knowledge about which waterholes still hold water in a drought, which paths are safe, which humans are dangerous. That knowledge cannot be bred into an animal the way coat color or a wagging tail can. It has to be learned over years, inside a family structure that a breeding program would have to break apart in order to manage. Different elephant families, even within the same region, pass down different habits, different alarm calls, different preferred routes to water, the kind of variation researchers now describe as a form of culture. A domesticated breed is defined by uniformity, generations of animals converging on the same predictable temperament through careful selection. An elephant family is defined by the opposite, a set of habits specific to one matriarch's lifetime of experience, which makes the species a poor fit for the standardization that domestication requires. Adult bull elephants complicate the picture further. Periodically, a mature bull enters a hormonal state called Musth, marked by aggression, restlessness, and a sharp spike in testosterone, a phenomenon the researcher Joyce Poole documented in detail while working alongside Moss's team through the 1980s. A bull in Musth is dramatically more dangerous and less predictable than the same animal outside of it, and there is no quick way to breed that instability out of a population, because it is tied to reproductive biology that took millions of years to evolve. Horse breeders manage stallion aggression by controlling access to mares within a herd hierarchy horses already understand instinctively. Elephant breeders would be managing something closer to a periodic, unpredictable behavioral storm arriving inside an animal that outweighs a small car. None of this means humans failed to work with elephants. They succeeded spectacularly, just not through domestication. What developed instead, across India, Sri Lanka, Thailand, and Myanmar, was an entirely different relationship, capturing wild elephants and taming individual animals through intensive, skilled human contact, generation after generation of mahouts repeating the same process with a fresh wild animal each time, rather than breeding tameness into the species itself. The ancient Indian statecraft manual, known as the Arthashastra, attributed to the advisor Kautilya and dated to roughly the 4th century BCE, describes an entire government office dedicated to managing elephant forests, protecting wild herds as a state resource to be captured and trained, rather than farmed and bred. The mahout tradition that grew from this system was, and still is, an apprenticeship passed between people, not a genetic program passed between animals. A boy assigned to a particular calf might spend the rest of his working life with that one animal, learning its individual temperament the way a parent learns a child's. In parts of Thailand and Myanmar, the earliest stage of training a young captured elephant sometimes called the crush in English-language accounts, involved days of confinement and controlled stress, intended to establish the obedience a mahout would rely on for the rest of the animal's working life. A harsh method that reformers within the industry have spent recent decades trying to replace with slower, less coercive techniques. Either approach started over completely with every new elephant, because there was no calmer, pre-adapted generation waiting in reserve to make the job any easier. The British forest officer George Peter Sanderson described the capture side of this tradition in detail in his 1878 account of his years hunting elephants in southern India, documenting the kedda, a large funnel-shaped enclosure into which entire wild herds were driven and trapped, sometimes involving hundreds of beaters working for days to close the trap without triggering a stampede. Once captured, wild elephants were calmed with the help of kunkis, elephants already tamed by previous generations of the same process, walked in alongside the terrified newcomers to show that nearby humans did not necessarily mean danger. The wild elephant was not bred into cooperation. It was persuaded into cooperation by animals that had already been persuaded themselves, one individual life at a time. This is the part of the elephant story that looks the most like domestication, and is, on closer inspection, the opposite of it. A domesticated horse is genetically different from a wild Przewalski's horse, shaped by thousands of years of selective breeding for traits like ease of handling. A tamed working elephant is not genetically different from a wild elephant standing in the forest a few kilometers away. Every skill it demonstrates, standing still to be mounted, responding to a mahout's foot pressure and voice, working in step alongside a chain and a log, was taught to that individual animal within its own lifetime, using methods refined and handed down through human teaching, not elephant breeding. If you're hooked on this story, make sure to subscribe and turn on notifications so you never miss an upload. Your support means everything and helps me bring you more emotional stories like this one. If any human institution had the resources and the motivation to force elephant domestication into existence anyway, it was the Ptolemaic Kingdom of Egypt in the 3rd century BCE. After Alexander the Great's general Ptolemy took control of Egypt following Alexander's death, his successors ran into a strategic problem. Their rivals in the Seleucid Empire, ruling much of the former Persian territory, had direct trade routes into South Asia and access to Indian war elephants that had already proven devastating on the battlefield. Alexander himself had watched King Porus deploy them against his own army at the Battle of the Hydaspes around 326 BCE, and every general who came after him understood exactly what they were capable of. The Ptolemies could not easily buy elephants from a hostile rival empire, so Ptolemy II, who ruled through most of the middle of the 3rd century BCE, attempted something almost nobody else in the ancient world tried at that scale. He commissioned expeditions down the Red Sea coast of Africa, specifically to capture wild African elephants, establishing hunting and holding stations at sites including Berenice Troglodytica and Ptolemais Theron. According to accounts preserved by the ancient writer Agatharchides of Cnidus and studied in detail by the modern historian Stanley Burstein, trained hunters, handlers, and soldiers were stationed along hundreds of kilometers of coastline for decades, with the explicit royal goal of supplying a standing corps of war elephants without depending on anyone else for them. In northern India, around the same broader period, the Mauryan Empire under Chandragupta ran a parallel system, protecting elephant forests under direct state control and staffing them with hereditary elephant keepers, exactly the kind of long-term, well-funded management that a domestication program would need. Centuries later, the Khmer Empire centered at Angkor and the kingdoms of Ayutthaya, in what is now Thailand, ran similarly organized elephant forests of their own, protecting capture and breeding grounds under royal law and punishing unauthorized hunting severely. Across more than 1,000 years and several unrelated civilizations, the same solution kept appearing independently: manage the wild population carefully, capture what is needed, and train each animal individually, rather than wait for a domesticated bloodline that never arrived on its own. Neither effort produced a self-breeding herd. Both remained entirely dependent on continuous fresh capture from wild populations for their entire existence, not on captive-born calves quietly replacing the previous generation year after year. The historical record of the Ptolemaic core in action is unflattering at best. At the Battle of Raphia in 217 BCE, the Ptolemaic African elephants reportedly fled in terror from the larger Asian elephants, fielded by the Seleucid army, a size and confidence gap that reportedly startled commanders on both sides. Part of the mismatch came down to biology rather than training. The animals available to Ptolemaic hunters along the Red Sea coast were African forest elephants, a smaller subspecies than the Asian elephants fielded by the Seleucids, and no amount of skilled handling could close a gap in raw size between two different kinds of wild animal that neither side had bred for the battlefield in the first place. Hannibal's own war elephants, marched across the Alps into Italy in 218 BCE, suffered a similar fate 2 decades later at the Battle of Zama, where the Roman general Scipio drilled his infantry to open lanes and let the charging elephants pass harmlessly through the ranks, turning what should have been a terrifying weapon into a liability that trampled its own retreating side. An animal bred over generations for calm and predictability does not behave this unpredictably in the one environment it was supposedly built for. The clearest modern evidence for just how hard elephant domestication remains comes from Myanmar, home to the largest managed population of working elephants left on Earth. For over a century, the state-run timber industry has kept detailed records on thousands of elephants used to haul teak logs through terrain too steep and dense for machinery, producing one of the most complete demographic datasets that exists for any large mammal living in human care. When the biologists Mirka Ladenpera and Virpi Lumma of the University of Turku analyzed these records, comparing elephants born in captivity to elephants captured from the wild as calves and raised in the very same camps under identical conditions, they found something that should not be true of a genuinely domesticated species. Captive-born elephants showed lower survival rates and reduced reproductive success compared to their wild-born counterparts, even generations into the program. If Myanmar's timber camps had actually been domesticating elephants the way ancient herders domesticated horses, captive-born animals should have been thriving at least as well as wild-caught ones, shaped by selection to fit the very environment they were born into. Instead, the opposite pattern held, and it suggested the whole population still depended, functionally, on genetics and instincts shaped entirely outside human control. Roughly a third of all Asian elephants alive today live in some form of captivity, according to conservation estimates, which makes the Myanmar findings more than an academic curiosity. It means the largest managed elephant population on the planet is still, generation after generation, quietly borrowing its genetics from the wild, rather than generating them on its own. Zoos worldwide hold a far smaller number of elephants by comparison, and even with modern veterinary care, climate-controlled enclosures, and reproductive technology unavailable to any timber camp, zoo breeding programs have struggled with many of the same problems. Low conception rates, stress-related reproductive suppression in females housed away from a full multi-generational family, and calves that, when they do arrive, still take longer to reach adulthood than an entire elephant management career. Zoos and conservation programs have tried to close this gap with reproductive science rather than generational selection. The veterinarian Thomas Hildebrandt, working out of the Leibniz Institute for Zoo and Wildlife Research in Berlin, spent the 1990s developing ultrasound techniques detailed enough to make artificial insemination viable in elephants, a genuinely difficult achievement given that a female elephant's reproductive tract can run more than 2 meters from entrance to uterus. His work led to Kondula, a calf born at the Smithsonian's National Zoo in Washington in 2001, one of the first elephants anywhere conceived through artificial insemination. It was a real scientific breakthrough, and it changed almost nothing about the underlying math. An elephant pregnancy still takes 22 months. A calf still takes over a decade to reach breeding age. Several zoos, faced with the combined cost and poor track record of captive breeding, have wound their elephant programs down entirely, rather than keep trying. A self-sustaining, genetically distinct, human-shaped elephant population still does not exist anywhere on the planet. Step back from the specifics, and a pattern shows up that reaches well beyond elephants. Every animal humans have successfully domesticated shares a life built for speed, fast to mature, fast to breed, willing to reproduce inside a human-controlled space, and organized into wild social groups, with a hierarchy humans could step into and redirect. Cattle were reshaped from aurochs beginning around 10,000 years ago, in the region now called the Fertile Crescent. Dogs branched off from wolf populations even earlier. Both started from animals that already lived in structured groups a human could join or dominate. Elephants have a social structure too, arguably a richer one than either, but it is built around multi-generational female knowledge and unpredictable bull behavior rather than a simple hierarchy a handler could substitute themselves into. The same intelligence, memory, and social depth that make elephants so remarkable to watch in the wild are, mechanically, part of what has kept them wild through 4,000 years of close human contact. The cheetah, teased earlier in this story, makes the same point from the opposite direction. Tamed by the thousands for royal hunts from ancient Assyria through Mughal India, a captive cheetah successfully raising cubs was so rare across recorded history that some accounts treat it as close to unheard of. Modern reproductive biologists studying captive cheetahs have found unusually high stress hormones and low genetic diversity working against them. A different mechanism than the elephant's slow calendar, but the same outcome. A species tamed by the thousand without anyone ever managing to breed it on human terms. There is something almost inverted about the whole story. Horses became faster, calmer, and more useful to humans specifically because their biology allowed rapid, repeated genetic reshaping across generation after generation of selective breeding. Elephants became just as useful to humans, in some ways more useful given their sheer strength, without that reshaping ever happening, because their biology never allowed enough generations to pass within the span of any single human effort, royal or otherwise. What looks, from a distance, like one long, unbroken 4,000-year partnership between people and elephants is, at the genetic level, thousands of separate, individually negotiated partnerships, each one starting from scratch with a wild animal and ending when that particular elephant's working life ended. A research institute starting a genuine elephant domestication program today from a clean slate, with modern genetics, unlimited funding, and the full backing of a government, would still be bound by the same calendar. The first generation of calves selected for calmness would not be ready to breed themselves until sometime in the 2040s. Their calves, the second generation, would not arrive until the 2060s at the earliest, and the 10th generation, the point at which Belyaev's foxes had already grown floppy ears and started seeking out human affection, would not exist until sometime near the year 2200. No institution founded today is likely to still be running the same breeding program 2 centuries from now, and that, more than any single fact about size or diet or temperament, is the real reason the domesticated elephant has never existed and likely never will. Every elephant alive today that hauls logs, walks in a temple procession, or stands quietly while a veterinarian runs an ultrasound over its reproductive tract carries, in its genes, the same wildness its ancestors carried when the first Indus Valley trader carved an elephant into a stone seal 4,000 years ago. 10 generations turned Belyaev's foxes into something close to dogs within a single decade. The same 10 generations would take an elephant breeding program well over 2 centuries to complete, longer than most of the empires that ever tried to run one managed to survive. Humans did not fail to domesticate the elephant because they lacked patience, skill, or desire. 4,000 years of mahouts, keddas, kunkis, royal hunting stations, and modern reproductive science prove exactly the opposite. Humans simply ran out of generations before the elephant ran out of wildness. Every mahout who ever raised a calf from capture to old age was, without knowing it, running a domestication program with a sample size of 1, starting the clock over from 0 the moment that particular elephant died. Multiply that by 4,000 years of individual lifetimes, empire after empire, family after family, and the total number of true generations of selective breeding still adds up to 0. Thank you so much for watching until the end. If you loved this story, check out the other videos on your screen now. I think you'll really enjoy them. And don't forget to subscribe if you haven't already. See you in the next story.